right. Welcome. Let's talk a little bit about what we're going to do today here. So I want to talk about the focus on designing microservices. I'll spend a little bit on design principles we are familiar with. We'll talk about microservices a little bit, and then we'll talk about how some of those ideas we are so familiar with, when do they apply, maybe when they don't apply, how do we think differently? Uh, the best time to ask questions or make comments is anytime you may have a question or a comment. So don't hesitate. Just grab my attention and ask your question. I'll be delighted to take your questions or thoughts. So with that said, when it comes to good design, what are the things we often talk about when it comes to design? One of the very first things we talk about is extensibility. We want our software to be extensible. But as it turns out to be, I often say that extensibility is a slippery slope. This is one of the most dangerous things I would argue that we actually do when it comes to developing software. So I'm going to say extensibility is a slippery slope. And the reason I say it's a slippery slope is if you really think about extensibility, what does extensibility really mean? Extensibility is the ability for us to create a code so the code can accommodate a reasonable change in requirements with minimum change to the code. That's what we are really trying to do with extensibility. But unfortunately, what happens with extensibility? For good extensibility, you could say, so for good extensibility, we need really good anticipation. So if you can anticipate, right? So if you can anticipate really well, you get extensibility. If you don't, you end up with, unfortunately, unnecessary complexity. So how many of us have seen this in our own experiences, right? You are trying to create an extensible code and you build all this massive amount of interfaces and hierarchies with the hope that when a change comes, you can easily handle it. But what happens oftentimes? The change that comes is not the one you thought is going to come. Now we got two problems. One, you got to write code to do what you didn't expect, but the code you already have makes it harder to make the change. I often say code is like people on a crowded bus. The more you have, the harder it is to get new things on board, right? So that's basically the problem we often have is it's really hard to make changes to software the more code we actually end up having. So the unnecessary complexity comes from that extensibility that is not going to really be the case. It really takes a lot more effort to know what to design for and to anticipate well is really difficult in general. So that is something we need to keep in mind when it comes to system design and how we can be cautious in bringing that together. We talk about reuse. Well, reuse is the other holy grail in software development. We don't want to create code that we can use. We want to create code that can be reused. But in general, though, think about this for a minute. For a code to be useful, it's got to be specific. For a code to be reusable, it's got to be generic. It's very difficult to create a code that is specific and generic at the same time. To be able to create something that's reusable comes with a lot of experience, not experience writing code, but experience understanding the domain for which we are writing the code as well. So this is another area where we struggle a lot and the results are very mixed when it comes to achieving the goals, if you will. We all have talked about solid principles. The principles like single responsibility principle or open closed principle, list constitution principle, or interface aggregation principle, or the famous dependency inversion principle. We often use solid principles. But again, having said that, principles are useful. Don't mistake me for saying that. But we can also use principles in the wrong way. I've actually worked with a lot of teams where I would ask people, why did we create this code so complex? And their answer oftentimes is, what do you mean? We wanted to use this principle in this case. Well, yes, you wanted to use the principle, but did it help us in this particular case, or did it overly complicate the code? That's one of the dangers of design, is that we can bring in unnecessary complexity into the system we are designing, and we have to be very careful about it as well. Especially things like single responsibility principle is very confusing oftentimes, because we are not really able to clearly say what that word responsibility means in a context. So in concept, we think these are good principles, but in practice, we find it hard to use them in a sensible way. One of my favorite principles is the Yagni principle, which stands for you aren't going to need it. And so you aren't going to need it, or Yagni, and you aren't going to need it. And basically, in this case, let's say need it. And I often put a little yet in here in parentheses. This is just the things that I add. I call it the Yagni why. Because if you tell the programmers you don't need it, they get upset. But if you tell them you don't need it yet, they're very happy about it. They're like, can I do this tomorrow? You keep saying yes until you never do it and release the product without it. This is one of the problems we often have, is we love writing code. I often say programmers are to code like dogs are to frisbee. The minute you throw a frisbee, right, the dog doesn't have to sit there and analyze and say, should I go after it, right? It just goes after it. That's what programmers are. You tell me a problem, before you could finish it, I've got the code ready for you, right? We love writing code. But the question is that the code we should be writing really? Yagni tells us restrain a little bit. But here's what I love about Yagni. So if you put Yagni on one side, if you will, and then on the other side of this is the beautiful extensibility you can put. And what you really want to achieve is a nice balance between the two. Because Yagni says, don't do what you don't really need or fully understand. Extensibility says, think about the future, look at what's going to happen. And neither one of them is actually correct. If you only focus on extensibility, you may end up with more code than you need and complexity. If you only focus on Yagni, you may not really create code that may actually be needed. So what you want to do is to strike a balance between the two, so that you can have enough of the planning for what's going to be ahead, but not go overboard with it as well. And so that it brings you the nice balance between the two. One other principle I really like is the dry principle. So what is the dry principle? Dry principle is really talking about essentially the idea of every piece of code should have a single, unambiguous, authoritative source of representation. So you don't want to duplicate a logic, decisions, properties, values, anything that you keep in your application, you don't want to duplicate it. But oftentimes, people misunderstand dry to be mundane copying and pasting of code. No, copying and pasting of code is a violation of dry, but dry is more than copying and pasting code. So what is really dry in its full measure? If you really think about dry in its full measure, you could really say it's a duplication of effort, not just duplication of code. So duplication of effort. I follow this principle. Unless something deeply gives you pleasure, intellectual pleasure, don't repeat it. So essentially, this is intellectual, this is worth engaging in, repeat it. But if it is not intellectually interesting as a human, you shouldn't repeat it. You should automate it so that you don't have to do it over and over and over. And dry is broader than just duplicating code. So for example, if your team does manual verification or testing, that is a violation, you could say, right? Violation of dry. Because if you're repeatedly manually testing your code, that's a violation of dry. Because every time anybody touches code, because software is a nonlinear system. You could break anything anywhere. So as a result, you're going to be constantly running these test cases manually. That's a violation of DRY as well. You don't want to be doing this. In a similar way, if your team does manual deployment, if you will, of the software, that is a violation of DRY as well. So one of the things that I learned really with a lot of effort is how can I automate my deployment? In fact, it took an effort to do it. But guess what? That effort has paid several orders of magnitude. So now I write my code and I do a commit. If the test passes, it automatically deploys the application on the cloud. I don't have to waste my time deploying my code. And I travel a lot. I'm in airplanes almost every week, multiple times. And I was mentioning this to a friend of mine, and he just noticed something I didn't realize. He said, Venkat, did you notice while the rest of us deploy up to the cloud, you actually deploy down to the cloud, he said, because I'm usually at 30,000 feet when I write code and deploy it. So my time is more productive because I write code on airplanes and I just do a commit. I don't have to waste my time deploying. So I deploy my applications multiple times in a flight, not even on a day, right? When I take a long flight, I can just continuously keep deploying my applications. And that's very high amount of productivity for what I do. And that's not a violation of DRY because it's automated. So those are good things. We want to write code with high cohesion. So what is cohesion? Cohesion is where like things are together and unlike things are apart. But you want to really understand why you want to do these things, right? So what does it mean to be highly cohesive? So essentially, when code is highly cohesive, you could say all things together change for the same reason. So in other words, we minimize, you could say, the frequency of change. So that's basically why you want to make code cohesive. This is one of the things we need to do is you don't absorb the principles just by the names of the principles. You want to tear it apart and ask the question, why do I have to do this? What benefit does it give me? Well, when I make the code cohesive, it reduces the frequency of change to the piece of code. If it changes less frequently, that's more stable. When I have to make a change, I can get in and make the change more easily and not have to deal with the parts that I don't need to be concerned with. It reduces the cost of change and the frequency of change as well. So it's both the cost, if you will, and the frequency, if you will, of change is the reason to go for high cohesion. Similarly, low and loose coupling. You want loose coupling. You don't want to have tight coupling. So you want to depend on an interface than a class as much as you can, but you also want low instead of high coupling. You want to depend on fewer things. But again, why that is the case? So essentially, the reason is, more and the tight coupling increases, right? Increases the cost of change and makes it harder to test the software as well. Again, you want to really understand why, right? I'm a why kind of a person. Why do I care about this? Well, because if I lower coupling, I lower the cost of change. I make the system less fragile, right? So it's really related to fragility, if you will, when it comes to the system, and you want to be able to deal with less fragility as much as you can. That's part of the reason to do this as well. And it also makes it easier to test if you lower the coupling and loosen the coupling. And one principle that's extremely important is encapsulation. So if you ask me, what is encapsulation? So encapsulation, they say, is information hiding. But so to me, that phrase, it's information hiding, doesn't quite cut it. I'm like, why do I want to hide information, right? So it's not actually information hiding. In fact, you want to provide more information, in my opinion. So what is it really? It really is, it is the separation of the how from the what. So in other words, you want others to know what you provide and not know how you provide it, right? So essentially, what's the benefit? The benefit is they can be more stable to your internal changes, and you can be less rigid and more flexible to change, right? To change because why? Because you won't essentially affect others directly. So this is the reason why encapsulation is extremely important. You are saying, I'm going to separate the what from the how. I can change how I do things any number of times, but as long as I give you the what and keep the what consistent, and then this is basically the separation of the interface, what you can do with things from the implementation of how you actually accomplish it. So these are the fundamental design ideas, concepts, constructs we follow in design. And this is what we've been doing in traditional software design. So the question I want to ask is, we know these principles, we have used those principles, we have benefited from those principles, but do those principles still make any use? Are they relevant for us to design microservices? Or maybe those are not valid anymore, or maybe they're more valid, or to a different extent, what can we think about? So let's step back for a minute and ask the question. But before that, let's take the word microservice. So microservice, let's pause on that for a minute before we go further. Now, this is one of the problems in our industry. We really don't know how to name things. It's really hard for us, right? Didn't they say that naming is one of the most difficult problems in computer science? That's not in variables and function names. Anything we want to name, we really are bad at naming it, right? And so the problem is we would struggle to give good names, and we come up with really terrible names that don't even tell us what it is. Like no SQL. Like why? Why? What does no SQL mean? And no SQL is actually you can have SQL. So now you're scratching your head. What is no SQL when you can have SQL in it, right? So that's confusing. And I ask people, why do you say it's wireless technology? What do you want me to tell me it's a less of something I don't use, right? What do you don't have in wireless? I don't have wires. Why don't you tell me what it is instead? Well, we called it wireless. Or you go to the kids and say it's cordless, and they're like, what is the cord in the first place? And why are we having less of it, right? So we really are having a hard time telling what these names are. And what bothers me so deeply is microservices are neither micro nor services. And that's the sad part of it, right? So, I'm building a microservice. What is a microservice? It's neither micro nor a service. And that's why we call it microservice. We are so good at naming things for what they are not, right? And so, but what is really a microservice? You may be in a conference, you may be having a lunch, or in a user group, and somebody comes to you and says, what are you working on? You tell them, I'm working on a set of interconnected applications. And they look at you and say, that's boring, right? But you just told them you're working on microservices. But the point is, we lose sense of what we do. I'm going to say, I was speaking in a conference in Gdansk, Poland, and in my talk, I said 80% of the people who claim they are building microservices are really not building microservices. And somebody tweeted and said, oh, Venkat is saying in his talk that 80% of people building microservices are not building microservices. And somebody replied to the tweet and said, well, he's wrong. That number is 90%, not 80%. So the point is, we tell everybody we're building microservices, but what is microservices? I cannot tell you that so many people who tell you they're building microservices are actually building services, not microservices. They want to tell you, we're building microservices. Well, but what you're building is a service, not a microservice. But I want to say something. I was talking to a company actually here, and I was explaining things, and the developer said, okay, let me explain to you what I'm building, and maybe you can give a name for it. I said, go for it. I was very quiet. I listened to it, and he took the time to describe the system he is building. And after he finished it, and I said, okay, now that you've described everything you're doing, let me tell you what you're building. You're building an enterprise application with web services. And then he said, can you repeat that for me? I said, you're building an enterprise application with web services. And there was a long pause. And then he said, okay, I heard you, but is it okay if I still say I'm building microservices? And this is the desire to put the word because everybody else is saying it. How come I not? I mean, how could I be in a conference and sit next to people and not say that I'm building what I'm not building, right? So that's a pressure we have in our minds. So what is a microservice? So the microservice is a set of interconnected applications. It's modules that interact over the network. If you describe it that way, it is so boring, isn't it? And maybe that's what we should do. Describe it that way. It's so boring. We will not build it until we really need it. And most people, I had a manager call me up and said, everything that could go wrong has gone wrong. And I asked, why are you building microservices? And the answer was, what do you mean? We're supposed to build microservices, right? Because everybody tells me you got to build microservices. So a lot of people didn't even ask the question, why should we build it? So, and then there are these misconceptions that people often have. For example, somebody said to me the other day, in a meeting, he suddenly said, whoa, that's too big for a microservice. I'm like, hang on a second. What do you mean it's too big for a microservice? I mean, do you take your code and you put on the scale, oh, this is 2 kilograms more. This is not a microservice. Maybe we can remove this part. Okay, that seems to be microservice now, right? This misconception that somehow microservice should be of a certain size. There is no such thing. So microservice, the word micro is not about the service. This again is where, right? This is why I often tell people we need to have critical thinking. We need to ask the question, what is this and does this make any sense? So if I tell you arbitrarily, your code, your body of code has to be this small, and anything more than this, boom, you're out of control, that's not valid. So what does the word micro in microservice really mean? I'm going to ask you the question to reframe that thought for a minute. And that is micro in microservice. A service is like the word micro in a microscope. So do you ever need a lens to find where the microscope is? Do you say, excuse me, I don't know where we left the microscope. We need people to search for a microscope. Oh, there we found it. Here's your microscope, right? A microscope is actually pretty big. Depending on the microscope, the smaller what you're looking in, the bigger the microscope often ends up being. So a microscope is a device, but why is it called a microscope? Because it really is what it takes a look at is micro. So the microservice is not about the service, but it's about the context of the domain that we are really building. That's what micro is. So the micro really is about the domain, not about the code or the service or the application you are building. It's about the domain. So it's really bringing this to the bounded context of what you're building. So the micro is about the scope in the domain, you could say, bounded context into which we are building this particular application. That's what you're really focused on in terms of microservices. So the question then is, how are microservices different from monoliths? This is another problem we often have. So we often use the word, something like, for example, we say monoliths versus distributed, right? Distributed, you could say architectures. Now, this is very confusing. If I tell you monolith versus distributed, what does that convey to you in your mind? Oh, if monolith versus distributed, then monoliths are not distributed. I want you to raise your hand if the following is true. Raise your hand if you have ever built an application in your life where your application had exactly one thing. It never communicated to another system, whether it's a database or another service or an external system, just about anything. It was a blob. It never spoke to anything. Raise your hand if that's true. Only a few, right? What was that you built where it never talks to anything? A command line. What was that? That's pretty useless stuff, right? So pretty much anything useful, we're not going to build it, right? I have been building software for almost 40 years. And even I never wrote an application that never talked to anything, right? Out of school 35, 40 years ago, the first application, commercial application I wrote had a database on a different system, had application servers on a different system. The desktop was on a different system, and they all had to communicate back to each other. So I've never built a system that is not distributed ever, right? Anything non-trivial. So the point really is, well, what does it mean then it's a monolith? Well, we got to keep in mind that monoliths, are distributed. So there is no monolith that ever is a single blob that never talks to anything. So the question then is, what does it mean to be a monolith versus distributed? It is not about the execution in execution, but it is about the unit of deployment. So essentially, it's about the unit of deployment. So in other words, a monolith has a single unit of deployment, versus you could say versus a distributed architecture, and of which, like for example, like microservices, you could say have multiple units of deployment. So it is not really about, right? It's not about really your execution. So when you're executing your application, you have multiple parts that you need to talk to. I'll be very proud to tell you this. I've got a number of monoliths in production today. I will not be hesitant to tell you. You're going to say, oh my gosh, you are talking, you use monoliths? Will never sit in your dinner table, right? That's fine. I'm happy to have the food alone if that be the case. But the point really is, I never will shy away from building what serves my business. And you say, how's it going for you? I love it. You know why? Because monoliths are simple to build. And why would I not want simplicity? Monoliths are less expensive to build. Monoliths are easier to understand. Monoliths are easier to hire people. You can go down to Walmart and outside there are people standing. You can tell them, you want to come build monoliths? They're happy to come with you. I'm sorry that I said Walmart. You can find them on Home Depot as well, or other places you want to go to. The point is, it's very easy to hire people because we're all experienced in building it. And we're going to falter less as well. If you're a startup, you want to build monoliths. Why? Because 90% of the startups don't survive, right? It's not a negative. That's the world we live in. If you ask, I'll give you a random question. Throw a number at me. In 1895, can you tell me a number of car manufacturers that were there in the world? 10. 10, you said. 1. Zero. go in the other direction. 120. 120 car manufacturers in 1897. And they came down to the 10 or so by 1910. Over 110 manufacturers died. The companies you hear about are the ones that survived. But for every company that survives, there are thousands that never made it. That's the way the world is. So startups don't survive for more than 5 years. I had a business partner. One day he called me and said, "Congratulations." I said, "What did I do? Did I become just older? Is it my birthday? What happened?" He said, "Do you realize what today is?" I'm like, "No, I'm realizing I had bugs to fix, but what's going on?" And he's like, "Today is the 5th anniversary of our company." I said, "Well, we had 2, 3, and 4. Why should we be excited about?" He said, "Most companies don't survive 5 years." I didn't know that. He's the business guy, right? And that's like, whoa, we survived more than 5 years. We should celebrate, right? So the point is, if you're building a startup, what is your goal? Your goal is to see if your company will survive. And you want to get to releasing a product quickly. And you want to get to that at the simplest way possible and less cost. Microservices are more expensive and take more effort and require more monitoring, more observability. Everything is more. Why would you want to do that? So essentially, it really comes to simplicity. There are times when it makes really good sense to build it. So monoliths have a single unit of deployment. So if you ask me, what do I think of my applications that are monolith? I love them. You ask me, is there any problem? I said, there's no problem at all as long as I don't change it. But the minute I have to change it, I got to be careful how I apply the change, because I've got to take all these parts and I got to synchronize the change for all the parts. I don't have the luxury of changing this and not changing the others, right? They're all intertwined, and that's a consequence of a monolith. Now, you ask the question, why do you want to build a microservice? Well, a microservice allows you to have multiple units of deployment. What that means is I can change this microservice and I don't have to change the other microservice. They can evolve at their own pace. But why do I want to have things evolve at their own pace? If I'm a large enterprise, a large company, whether I'm a big insurance company or a big bank, imagine this for a minute. I've got a monolith I've built, and this monolith has been built with a lot of different teams of developers, and they're all working on this code. And when they're all putting their hands into this one monolith, how do I change it? Very carefully. I've got to plan how I'm going to upgrade it. In the meantime, your business comes to you and says, "Hey, we just had a change in the tax rules. We got to recompute the way we compute the taxes. We need to deploy this. And here are the change in business rules." And you tell your business, that's not really hard to do. And the business is like, "Good. Thank you so much. When can you get this done?" "Oh, maybe in 3, 4 months. Like, what? 3, 4 months? Why do you need 3, 4 months? You don't understand software development, do you? Right? We tell the business we cannot change things so frequently. Why not? Well, because if we make this change, all the other parts of the application are going to break. So we'll first create a change request. And the change request will be reviewed by this architectural committee, right? But we know what architectural committee is. That's where innovation goes to die. And the minute they take a look at it, right, they spend the time reviewing it. And 5 months later, they say, "We got some questions about it." Questions about what? We don't even remember what you're talking about, right? And then they go through all this. Now they devise a change plan. And they tell, this team will change the schema. That team will change this code. And they all come together, and miraculously things are going to work in these 4 months. And the business in the meantime is like sitting and scratching their head. What's going on? Why you can't change these things really quickly? Well, what did we lose in the process? We lost business agility. We lost business agility because our business is screaming for help, and we tell them, "Be quiet now. I'll listen to you, but we will take our own time to make the changes." Then the company says, "Wait a second. Why did we create this monolith? Let's split this along the business lines This is your business that deals with tax information. This is dealing with inventory. This is dealing with other parts of the system. Let's create these microservices. Now, this microservice deals with how you will tax based on the sales. This is dealing with inventory. This is dealing with other parts of the system. Now your business comes to you and says, we got to change something in the tax. You said, no problem, we can do that for you. How long would you take? Oh, we can get this done in a couple of days to a couple of weeks. But wouldn't you affect these other parts? No, they are independent because they are governed separately. So the basic idea here really is fundamentally, the idea in this case is about autonomy. So that is the first and foremost difference between microservices and monolith, is the difference in the unit of deployment. So as a result, you can govern these microservices independent of each other. Now, of course, it's not that in governing these microservices, you're not telling the company, don't ask us when this will be done, we'll take our own time to do. Because eventually, these microservices rather, have to talk to each other. But they have to talk to each other in a more defined format. You need to have a proper versioning to talk to these microservices. If you don't think of these and randomly start changing these, then it's not going to work. I was in Austin and a lady came to me and said, we are building microservices. And I said, well, I'm so glad to hear that you're doing that. And then she said, everything is great, except we have one problem. I said, it's actually pretty good, right? If there's only one problem that you're dealing with, everything else is great. And then I asked her, can you tell me what that one problem is? And she said, yeah, everything is great, except when we change one microservice, everything doesn't work. And I looked at her and said, have you considered the probability that you say you're building microservices, but you're really not, right? So the point really is, if they are brittle, then we haven't taken the time to understand how to make them autonomous so they can communicate with each other. So one of the critical things here is to design microservices so that you can have proper semantic versioning so that they can communicate with each other. There's a rigorous way you go through in terms of how you can evolve. There's a way you manage minor changes and patches compared to major revisions. And this is going to require a fairly rigorous effort in building these and deploying these and managing them. How are these different from service-oriented architecture? I would say that both microservices and service-oriented architecture, both of them are distributed architectures. However, I would argue service-oriented architecture is probably, hands down, the worst thing that humans have ever done in terms of architecture. This was, you take all the bad ideas and put them together. That is service-oriented architecture. Now, I've seen companies suffer through this. Why? Because one of the main essence with microservices is, let's think about this for a minute, right? This is where life becomes really interesting. I want to ask you this question for a minute, right? So let me ask you this question and see what your reaction is. I want you to tell me the very first thing that comes to your mind, right? So, you ready? I'm going to say, on a table, I find a sock and a fork. What comes to your mind? Unrelated. Who said that? Thank you. Unrelated. What else? Come on. Louder. Come on. Where's the spoon? Where's the spoon? I've never heard that one before. What was that? Useless? What was that? Messy table whose kids are around. What was that? A little louder. A shopping mall. I don't know where you shop, my friend. A shopping mall. Yeah. Somebody asked me the question, which database this table belongs to? So, did you just notice something? We all carried our bias. That's the funny part. We all carry our biases because there is something we forgot to ask the question in this case, right? And that is context matters. Context matters. What if I tell you I'm in a museum and this table is a display of this world leader, and that was the day, the last day, that he was using the fork and the socks he was wearing? Now your perspective changes, isn't it? So context matters. So on one hand, you said, oh my gosh, a fork belongs in the kitchen. The sock belongs in the drawer. Nothing wrong with that. Or you say, I'm going to put the fork and the sock together on a table. What we just talked about, let's bring it to computer science programming. What we talked about is there are two ways to partition a system. One is called technology-based partitioning, right? Partitioning. The other is domain-based partitioning. So if you tell me the sock and the fork don't belong together, that could be a technology-based partitioning. But if you say they belong together, that could be a domain-based partitioning. And this is why I find computer programming to be frustrating and fun at the same time. Because I thought I know what cohesion is until one morning I realized I don't know what cohesion is. Because cohesion is like things are together. But how do you define what like things are? Are fork and sock like things? Or are they unlike things? Well, come on, who am I to say? Who are you to say? That's the whole point, right? The answer is, it depends. It depends is a good answer 99% of the time. You can give the answer, it depends. It's correct 99% of the time. One time you don't give that answer is when your spouse says, can we go shopping? It doesn't work that way, right? Yes, you say. Every time it depends. It depends on how you partition your system. Are you doing technology partitioning? Are you doing domain partitioning? With service-oriented architecture, we do technology partitioning. With microservices, we do domain-based partitioning. That is the fundamental when it comes to microservices. This is my microservice to take care of taxation from the business point of view. This is my microservice based on insurance claims. This is a microservice based on deciding on whom to insure and not to insure. These are based on the business domain, not on technology. The word client-server architecture was a giveaway, right? What's the partitioning there? Technology, obviously, right? Use client-server. You go to a bank and say, hey, we have a client-server. They're like, what is a client? What's a server? Is a client a customer? Is a server a teller at the bank? Because that is not a banking terminology. That's a technology. So how do you partition your application makes a difference, right? So essentially, when it comes to SOA, unfortunately, they focus on technology-based technical partitioning, whereas microservices focus on domain partitioning. If you're building microservices and you don't focus on domain partitioning, we're going to be in trouble. I had a gentleman come to me and said, we have built a fairly well-known bank. I cannot mention the name here. And he said, hey, we are building microservices and it's a disaster, he said. I said, you said you're building microservices. You use the word we. Can you tell me who we are? He said, I don't understand what you mean. We are building microservices. I said, I understand, but you are using the word we. Can you tell me who the we is? Oh, he said, oh yeah, I'm an architect. I lead a team of programmers. We are building microservices. I said, that's your problem. because you never invited your business into this. If your business is not there, then how could you do domain partitioning without your business being involved in it, right? So if you bring a bunch of programmers and say, let's build microservices, what will be the result? We will be building what we want to build, not what the business wants to build. So one integral part of building microservices is the business should be the driver and we should be the facilitators to make that happen. And if we ignore them, that's not going to be fun, right? So we need to really involve the business in building it because it's driven by this domain partitioning. We need to understand, have the conversation with the business to bring it. So the key considerations in building microservices, the first is autonomous deployment of services. So you must be able to deploy one microservice and evolve it and not affect other microservices. You say, but wait a minute, nice theory, Venkat, but in practice, they got to talk to each other. Oh, totally. That's why you have to have very rigorous semantic versioning. And it requires more effort in how you evolve this moving forward so that they don't become brittle and break on each other, so they can be evolved separately. But autonomous development of services. One microservice can develop in isolation of another microservice. They're not sitting and talking to each other and trying to decide on how they affect each other. Isolated deployment. You can deploy a microservice and redeploy it any number of times without affecting other microservices. Now, that doesn't mean a microservice that needs another service is going to be able to function without it. But one of the things I would often ask is, microservices, when they talk to each other, that's got to be a coarse-grained communication, not a fine-grained communication. If you're very chatty with the communication and you say, I cannot do anything without that service, well, that's exactly right. That's a service, not a microservice. So when companies put the word microservice or everything, that doesn't make any sense. You need to have a really nice boundary for your microservices and say, this box, there are services within this box, but that outer box defines my microservice. And the communication has to be coarse-grained between them, not fine-grained. And there's got to be separate governance between these microservices so that they can maintain this autonomy of development and isolation of deployment. So what are the key considerations that we need to think about? So one of the things we want to think about here is that when it comes to both life and programming, right? So you could say, right, in both life and programming, we have to constantly, right? So constantly evaluate trade-offs. This is what our life is. We have to evaluate trade-offs. And you cannot just have it all. Not going to happen, right? If you gain some, you're going to lose some. And you got to ask the question, is what you gain is so useful that it was worth losing something else? You chose to be here at the ungodly time of 8:30 in the morning. You lost a little bit of sleep in the morning for that, right? And I hope it was worth it. And if it was not, what are you going to say? Next time you're like, nope, I would rather get my extra sleep than go there on that time, right? And it's a trade-off. You chose that trade-off this morning. And you do this every single time, every single day. You're not just picking things. You are compromising on things all the time. And designing is no different than that. It's a trade-off. If you make that more explicit in your conversation, you are able to drive this a lot better than not acknowledging it. And then you feel the tension and you don't know what the tension is. So what I'm getting to is that there are very good software principles, but you can't use them all to the same degree. You have to compromise. We are not saying one is important and the other is not. That's not what we are saying, right? What we are saying is we are saying we have to lower the priority um, for some and increase for others in order to achieve the key goals. And what are your key goals? Those three things, right? So you need to ask the question, how can I get autonomy of development? How can I get isolation of deployment? How can I get separation of governance? So when it comes to microservices, you are asking, here are my key goals. What should I do to accomplish that? This is one of the toughest things we need to be aware of in our life. You don't apply principles and expect results. You ask the question, what result do I want? And then work your way from there. What principles can I use to get that result? In programming, the end has to justify the means. Otherwise, we won't stay in business. So if that is the goal I want to receive, what are the things I need to do? If I apply principles as the only most important thing, it'll take me to a place where I don't want to be. That may be good for a moral life, but not good for programming. Because in programming, the goal is the end result, right? For your business to survive. So what I'm saying here is, ask the question, what is more important? What is less important? So encapsulation. So if you think about it, we want business agility. So what does it mean? More the encapsulation is, right? The higher business agility. Think about that for a minute. How is that? If I encapsulate my microservice and you encapsulate yours, I don't know how you do things and you don't know and don't care about how I do things. I want to change things on my side because my business says change it, and I make a change to it. What's going to happen to your microservice? You're not affected. But if I tell you, make all your fields public, what would you say? You would say you need to be thrown off the stage, right? That doesn't make any sense. But what if I tell you, I've got one shared database that is used by all of the application? What's going to happen? Have you ever seen systems like that? That's called enterprise. We all have that, right? And somebody says, I want to change the schema. What happened? You completely blew your entire enterprise out of the water. So what do? They watch you very closely. If you say, I want to make a change to my schema, they walk you out, right? This happens, right? You probably go to an interview in a company, you're having a good time. They tell you, we got a great cafeteria. You want to come and have lunch with us? So you go there and you see that people are having a great time in the cafeteria, right? You've seen that. One table, they are talking about politics. In the other table, it's much worse. They're talking about JavaScript frameworks. And you're like listening to these. And then you look over, away from civilization, away from everybody else. In the corner of the room, there is one person sitting alone, facing the wall and eating quietly. And you ask, who is that person over there? They say, we don't talk about the person. Like, really, what happened? Well, he tried to change the schema 2 weeks ago, and he's on timeout for 3 weeks from now, right? Because what does the company care about? They don't care about business agility. They care about stability. When you come to work, what do they say? Don't screw up today. That's what they tell you, right? Because if you make any changes, if our systems break, you're going to be at fault. So everybody is very careful. Hey, I want to change it. No. write a change request first. Why? Then it's not your problem, right? We can blame somebody else for that. We are very cautious, right? What happened to business agility? Forget it. We're not breaking anything, right? But that's the problem. When you share a database to that extent, what did you lose? Encapsulation. If I tell you make the variables public, you're like, are you crazy? But we all make database schemas shared across the entire system, and we don't even feel a thing. So encapsulation is an extremely important fundamental that we want to think about. So more the encapsulation, higher the business agility, right? That's the first thing. Second, we want high cohesion. That's extremely important, isn't it? What do microservices do? They give you domain-based cohesion. What does microservice do? It deals with everything related to taxes. That's the only thing it's going to do. What about that? Nothing to do with taxes. That's domain-based. So it's a domain-based cohesion, not technology cohesion, right? Not technical cohesion. We have loose coupling and low coupling. Microservices, they talk to each other, but the communication is coarse-grained. You're reducing your coupling. Now, think about this for a minute. I just quick raise your hands, just for example, right? Who wants more reuse or less reuse? What do you think? More reuse? Yep. Look at the room, right? More reuse. Who wants more coupling, less coupling? No hands went up. We just contradicted each other, isn't it? Because what happens when you increase reuse? You increase coupling. You just said, I want more reuse, but I don't want coupling. How could you do that? So that's the fallacy we live in. We want this, we don't want that, but we don't realize we cannot have both. You cannot increase reuse without also increasing coupling. If you lower your coupling, what's going to happen? You're going to lower your reuse. If you lower your reuse, what are you going to increase? Duplication. You're going to start violating dry a little bit. Now you see where the problem is, right? You cannot just turn this on and go home. Because when you turn this on, that turns on the other way. And you're like, wait, okay, wait. How do I put them together? And if you're stuck with principles, you're going to have a really hard time. So you have to start compromising, right? So last responsible moment, this is something I love, is not jump on extensibility, but to say, hang on, let's wait until we see a little bit more about this. Let's understand more before we come to commit this. So think in terms of service boundaries. What is your domain boundary on this? And ask the question, different bounded context means different microservices in general. And the domain-based partitioning we talked about. We move towards domain-based partitioning so we can evolve these much more with business agility. And to ask the question, right? You don't go to work saying, I love duplication, let's do more of it. That's not your goal. But if you say, we want more encapsulation, we want better business agility, and because of that, we're willfully going to duplicate this data, then we can achieve this a little bit more. Now, immediately people tell me, oh my gosh, did you just realize what you just did? Your code is not going to be consistent because when you make a change here, that's going to be not consistent over there. If I ask you one request today, one request ever, never, ever, ever, ever go to your business and ask this fateful question. Do you want consistency? Worst question ever. Because you just freak them out. They don't know what this means, but they know they have to fear this. They watch you go to the bathroom from tomorrow. They will catch you on the way to the bathroom. You're building consistency, right? Just want to make sure. Because you just scared the daylights out of them. But the problem is, if you give them what they don't really want, you're not going to give them something they really need because it's a trade-off. You cannot have both. So if you told them reuse is important, well, you're going to increase coupling, whether you like it or not. And if you told them you really need to have instantaneous consistency, you lowered encapsulation. You cannot get that kind of business agility. So that's a trade-off. So the principles we have taken the time to learn over the years are still useful. But we have to ask the question, to what measure do we want to use them? And your goal is not to violate principles, that's clear. But your goal is not to follow the principles blindly, because you cannot achieve results by only following the principles. So that's really what it comes down to. So don't let your current perceptions influence your design. Be open to compromising, be open to trade-offs, be open to evaluate, but always start with the question, what do I want to achieve? And in order to achieve that, what are the trade-offs I should be willing to take? Then you have a chance of succeeding with it, rather than saying, these are the principles I want to follow, let's see where it takes us. Often it's not going to be very fruitful. And that's basically the idea, is these are good, but you need to know how to apply them. Hope that was useful. Thank you.